All right, so welcome to Nearpod lesson 4.2, How Ions Form. This is a reminder to title your notes, lesson 4.2, How Ions Form. And the key ideas you need to know from this video is know what is something called the octet rule, and then to also be able to predict whether an element will gain or lose electrons and how many electrons it will gain or lose when it becomes an ion. So go ahead and ignore these directions in blue for now. And something you need to remember from previous lessons is that ions are what we commonly call salts or electrolytes, right? So whenever you're drinking things like Gatorade to prevent dehydration or cramps and things like that, you are essentially drinking ions. And all ions are is basically salts. And salts are elements with either an overall positive or a negative charge. So some examples of ions we need in our body and that you can find in things like Gatorade or soy sauce or Pedialyte for babies is sodium, magnesium, chlorine, potassium, and calcium. But mainly you just need to notice that all of these either have a plus charge or a minus charge with a number next to them. So we're kind of going to talk about how these elements form in the first place. All right, so in this slide, we're going to go over how regular elements turn into ions and what that pattern is. So we did a little bit of pattern identifying when in our classwork today. And if you missed that, we're going to go over it again and clarify those patterns. So looking at the first two, I'm just going to look at the number of valence electrons each type has. So notice in this first example up here, this element has one valence electron shown in the black circle on the outermost ring. So remember, valence electrons are the electrons in the outermost ring, and I only have one. These white circles are all the spaces where these electrons can fit, right? So I have one valence electron and 7 spaces where I can fit, right? But when it turns into an ion, notice that that valence electron disappears. And underneath all this, so if I erase everything out here, right, all the white spaces, below I have 8 electrons underneath. So something I want you to notice for sure is that below this, there are 8 electrons underneath. Let's do this in orange. Right. In the second scenario, I have 2 valence electrons, 1, 2. So 2 valence electrons or electrons in the outermost ring, and 6 spaces on the outermost ring. And notice that when this element becomes an ion, right, it loses those 2 electrons. And again, if I ignore what's out here and I count out the number of electrons underneath, or the new valence ring, I have 8 electrons, right? So notice that every single time any element with less than 4 valence electrons total will lose all of their valence electrons and reveal the full ring of 8 electrons underneath. So whenever you have less than 4 valence electrons, they will give away all of the valence electrons they have. Right? Let's look at this next scenario instead. So here in this case, I have 5 valence electrons. So 1, 2, 3, 4, 5 valence electrons on the outermost ring and 3 spaces, right? And in this case, it's going to gain 1, 2, 3 valence electrons, making a total of 8 electrons on the outermost ring. So if I count out in ion form, in the ion version, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. In this scenario, I have space for 1, and I have 1, 2, 3, 4, 5, 6, 7 valence electrons, right? So this one, if I look on the other side, will gain 1. And if I count out how many valence electrons I have on total on the outside, I will have 8 electrons. So notice that every single time an element is gaining or losing electrons, all they want to gain or lose is 8, right? And if an element with more than 4 valence electrons, so any element that has more than 4 valence electrons, this one has 5, this one has 7, will gain the number of valence electrons they need to get a full ring of 8s. So when elements become ions, they gain or lose electrons in order to get a full ring of electrons. So the reason why it gets to 8 each time is because the goal of each element is to get a full ring of 8 valence electrons the easiest way they know how, right? So if I have less than 4 valence electrons, it's easier just to get rid of 1 electron than to find 7 more. If I have 2 valence electrons, it's easier to get rid of 2 than it is to find 6 electrons, right? And the reason why they want to get rid of them is so that underneath they have a total of 1, 2, 3, 4, 5, 6, 7, 8 electrons each time, right? So this one loses 1 because underneath it will have 8s. This one loses 2 because once it gets rid of those 2, it will have 8 as well. Right. On the other hand, if I have a lot of valence electrons, meaning I have more than 4, if I have 5 valence electrons, it's easier to look for 3 valence electrons than it is to get rid of 5, right? And if I have 7 valence electrons, it's easier to find one more than it is to get rid of all 7 of these, right? And once they find 3 valence electrons, they will have a total of 8 electrons, just like the other types, right? So 1, 2, 3, 4, 5, 6, 7, 8. If I count the electrons on this outer one, I will also have 8. So the reason why elements gain or lose electrons in order to get a full ring of electrons is because the full ring of electrons allows them to be stable, meaning that they're not reactive or explosive, right? So when elements or atoms have a full ring of 8 electrons, they will be stable, meaning they will not be reactive or explosive. So these are the 3 things you need to know about why elements become ions. They basically become ions or lose or gain electrons in order to get a full ring of 8 electrons because they need to be stable or not explosive. And elements that have less than 4 electrons in the outermost ring will lose all of their valence electrons because underneath they'll have a full ring, and it's easier to get rid of those few than to find 7 more, 6 more, or 5 more. Elements that have a lot of valence electrons, or 4 or more valence electrons, will gain the number of valence electrons they need to get a full ring of 8s, right? So if I have 5 or 7 valence electrons, it's going to look for either 3 electrons more 1 electrons more. If I had 6 valence electrons, it would look for 2 more in order to get a total of 8 valence electrons total when it is an ion. Some of you might be wondering what happens if I have 4 valence electrons. And elements with 4 valence electrons will go through a different process that we'll talk about in a different unit. All right, so here's a practice problem that you might see. And before we even do this practice problem, there are 3 things we need to remember, right? 1, if I have less than 4 valence electrons, it will lose all the valence electrons in order to reveal the full ring of 8 below. If it has more than 4 valence electrons, it will gain to get a total of 8 valence electrons. And the goal is always to get a full ring of 8 electrons total. We call that the octet rule. There is one exception, which we'll talk about in example problem 2. But let's do example problem 1 first. Go ahead and pause this video and see if you can do this on your own. If not, stay with me and then we'll go through this together. Right, so in this example practice, it says, given the elements on the right, determine the following. Will the elements gain or lose electrons? Well, looking at this elements, I know that it has 1, 2, 3, 4, 5 valence electrons. So it has more than 4 valence electrons. Therefore, it will gain. Right? So in this case, it will gain electrons. How many electrons will the elements gain or lose? Well, remember that whether I'm gaining or losing electrons, I'm trying to gain enough to get a total of 8. So here, I'm missing 1, 2, 3 electrons to get a total of 8 because I have 5 electrons, right? Remember the white spaces are missing electrons, so I'm missing 3. So therefore, it needs to gain 3 to get a total of 8 valence electrons. Right. So just so you see clearly, the 3 come from here. That's where they're going to go. Right? When the element becomes an ion, it will always have how many electrons? Well, once it gains those 3, it will have 8 valence electrons. And again, we'll talk about the exception later on. This follows the octet rule. Octets, right? Like octopus, a creature with 8 legs, or octagon, a shape with 8 sides. Oct meaning 8. All right, so let's go ahead and try this second problem. It's a little bit different, and this one is a little bit trickier. So here in this case, it's the same 3 questions, but I have a different elements. So it asks, will the elements gain or lose electrons? So here I have 1, 2 valence electrons in my outermost ring, right? So that's less than 4, which tells me it will lose these valence electrons. So lose valence electrons. Second question, how many electrons will the element gain or lose? Right? So the goal is always to have a full outermost ring. So in this case, it might be kind of tricky to tell because if I lose these 2, underneath it's not 8s, but it will still have a full ring, right? So in this case, it's going to lose 2 valence electrons. So it follows the same principle. So it will lose 2 valence electrons, right? Because once it gets rid of the 2, underneath it will have a full ring of valence electrons. So once I get rid of those 2 electrons, there's nothing in that outer ring. So it kind of disappears. And I'm left with a full ring of valence electrons. So the octet rule, the name is kind of incorrect. It's not always 8s. Sometimes it will be 2 valence electrons for smaller atoms, right? So when the element becomes an ion, it will have either 8s or 2 valence electrons. So in this case, because it's a smaller atom, the first ring can only fit 2, so it will only have 2 valence electrons. So at this point, you should be able to complete the questions on your own, but just in case, I'm going to do one more practice problem if you're still feeling kind of stuck and want to continue watching these videos. All right, so this is the optional example practice. Same 3 questions again, different elements on the right-hand side, and in blue are the 3 rules we need to remember. So question A, will the elements gain or lose electrons? So again, go ahead and pause this video and see if you can solve this on your own before I continue. So here you're going to notice if I count everything out, I have 1, 2 valence electrons. It is less than 4, so it will lose, right? So I will lose valence electrons. How many electrons will I lose? Well, if I get rid of all of the valence electrons, these 2, 1, 2, right? So if I have less than 4 valence electrons, it will lose all the valence electrons. So it will lose 2. Right? And it's going to lose 2 because underneath I will have a total of 8 valence electrons. So once I get rid of the 2, everything that I'm scribbling in pink kind of goes away. And what I'm left is just the black parts, right? So underneath I'm going to have 8 valence electrons total. So in this case, I will have 8 valence electrons total once it becomes an ion. So this pretty much summarizes what you need to know for how ions form. And you should be able to identify, 1, whether an element will gain or lose electrons, how many they will gain or lose, and what the octet rule is. In order to test your skills on that, you should see a couple of practice problems in the next slide. Please be sure to complete them for full credit.